The next presentation is optimal localization of DC-AC relay chips in high parallelism probe cards for enhancement of signal integrity. Junhee Han from SungKyunKwan University is going to present. Go ahead, Aya.
Hello, my name is Junhee Han, who will be presenting this time. The title of the paper is Optimal Localization of DC or AC relay chips in a high parallelism probe card for enhancement of signal integrity. As semiconductor technology advances, the number of the chips that can be fabricated per wafer has increased. However, the number of chips that can be tested at one time by the currently used automatic test equipment, also known as ATE, does not cover this. In order to increase the maximum number of chips that can be tested, research on branching lines is being conducted in a device called a probe card. The probe card connects the ATE and the wafer, and as the number of branches of the probe card increases, the number of chips that can be measured at one time increases. Branching types include MLC branch type and MTF branch type, and Figure 1 shows the structure of probe card, MLC, and MTF. MLC means multi-layer ceramic and MTF means multi-layer thin film. The MLC branching method is cheap but poor performance, and the MTF branching method is good but expensive. In this paper, we propose a branching method through buffers, and at this time, we will talk about how to place buffers correctly. Figure 2 shows the area of the target probe card. It is a probe card with a diameter of 520 mm, and the blue part is where various chips can be mounted. There are 8 areas of A, each 5,452 mm square, and there are 8 areas of B, which are 6,553 mm square. C area is 45,874. The area is 75,632 mm squared. The target total number of the lines is 15,020, and since AT has 59 lines, 60 branches must be made on the probe card. The chips to be deployed are power relay, STA, FPGA, regulator, capacitor, and buffer. Among them, the power relay is placed in the D area, and the FPGA and the regulator are placed in the B area. Therefore, it is possible to change the position of STA and buffer. The required number of chips, as you can see, especially in the case of a buffer, a total of 17,010 buffers are required because 18 signals per one line of AT are required. Figure 3 shows the cross-section of the probe card with the chips arranged. One of the possible deployed scenarios is shown in Figure 4. This is the diagram where STA is placed in the area B and buffers are placed in areas A, B, and C. In this case, the minimum and maximum distances that can be transmitted signals were calculated based on the cross-sectional view shown in Figure 5. As you can see, 20 mm is the shortest length, and 160 mm is the longest distance of buffer in A area. And buffer which placed in B area, the longest distance is 58 mm, and shortest distance is 7.4 mm. In Figure 6, the timing skew that can occur in the signal is displayed through the minimum and maximum distances calculated previously. It can be seen that skew can be reduced when A is the worst case and B is the best case, and when the buffer is placed in the center. So in this paper, we have talked about the correct placement of various chips in the probe card, and by arranging the buffer, the performance can be improved in the MLC branching method. In particular, it is confirmed that placing the buffer in the center shows the greatest SI performance. Thank you.
Have you thought about moving your buffer and driver ICs closer off the PCB, like onto the MLC of the probe head or something like that? Is that an option?
Yes, yes. In this paper, I show only one case of the placement scenario. I also moving buffers and driver IC more closer or some other places as many scenarios. But in this case, I only consider the SI performance of buffers. So I show only one scenario for that reason. Only shows SI performances.
Thank you.
I want to once again thank our sponsors who have made this event possible, our premier sponsor, Kohu, our emeritus sponsor, JonsTech, our honored sponsors, ISC, iWind, and TSC, our distinguished sponsors, Backer Hotwatt, Innovative Circuits Engineering, JMT, Nidec SVTCL, R&D Altanova, and UI Green, and our exhibitor sponsors, ELES, MJC, Phoenix Test Arrays, and Smiths Interconnect. So when you have a chance, please thank these companies for sponsoring, which has made this event possible and has made it available free of charge. And once again, I would like to thank Kohu, our premier sponsor, the market leader in test interface solutions for the most challenging applications, and ISC, the global #1 total test solution provider. So we thank them both for their leadership. And once again, I thank everybody for attending, and we look forward to seeing you again tomorrow at 7 a.m. Pacific. Thank you.